Last time we learned about the exact equation. For today's topic, it's gonna be the equation that is not an exact equation. And we're gonna try to make the equation which is not exact into an exact equation by finding the thing that called integrating factor. The integrating factor will be the thing that we use to make a non-exact equation to an exact equation. You may think that it's may difficult to get that guy. However, the thing that we can see for the first equation here, you have y dx minus x dy equal to 0. So for this one, if you have m, okay, so you have m and you have n. So you have m equal to y and you have n equal to negative x. So you check the m dy is going to be 1, okay? And you have dn dx is going to be negative 1. And so the equation turned out to be not exact. So when you have non-exact equation, you may think that, hey, can we just find something that make this equation turn out to be exact, okay? So the thing that you also see from this equation will be, it look like quotient rule. So if you recall quotient rule from last semester, you have d of x over y. So for d of x over y, it's going to be the bottom derivative of the top, which is dx, okay, minus the top, which is x, and derivative of the bottom, which is turn out to be dy. However, if you have this thing, it's going to be the top, the bottom derivative of the top minus the top derivative of the bottom, x derivative of the bottom. However, if it turns out to be the quotient rule, is going to have to be over the bottom square, okay? So the thing that you have is going to be, hey, this one is going to look like the quotient rule. However, it's not quotient rule yet because you don't have the bottom square. So we're going to just guess, okay? So this one is going to be from guessing, okay? So we're going to just guess that if you multiply the whole thing by over y squared, so if you just multiply this guy, so divide this guy by y squared, you would get, okay, so you would get 1 over y dx, okay, and you have minus x over y squared dy equal to 0. And from this one, you're gonna have new m and new n. Okay, so this one is gonna be my new m and my new n. So this one I use different color. So I'm gonna use the blue one. So this one is gonna be new m and new n. Okay, and we're gonna check dm dy, dm dy. So you have dm dy equal to, so it's going to be negative 1 over y squared because it's derivative of 1 over y. And you have dn dx. So it's going to also be 1 over y squared. And you see that they're identical. So this one gonna be negative 1 over y squared and negative 1 over y squared, and they turn out to be identical. So you have, it is turn out to be exact. Okay, so it's turned out to be exact. And when you have an exact equation, you're gonna just solve for uxy. So you have uxy given by, okay, you're gonna just integrate 1 over y dx. And when you integrate 1 over y dx, this guy will be x over y, okay? And you're gonna differentiate the y because you integrate with respect to x, so you're gonna integrate you're going to differentiate with respect to y. So this one is going to be negative x squared, not x squared, x over y squared. Okay, and you see that you have this one cross out. Okay, so you cross this one out and you're gonna add by integrate 0 dy. Okay, so it's gonna be integrate of 0 dy, and integrate 0 dy turn out to be 0 plus c. Okay, so it's gonna be 0 plus c. So you would have uxy equal to x over y plus c, okay, from this calculation. And you also see that this one turned out to be d of x over y, okay, which is your u, okay, so which is your u. Okay, so it's going to be kind of the same. It's come from the total differential, or it's basically come from just the quotient rule. Okay, they are from the same idea. So for this one will be the general solution. So it's going to be uxy equal to 0 is the general solution. Okay, so that is going to be how we solve exact equation. Oh, sorry. So the equation that is not exact equation by making it to be an exact equation, and you gonna just solve by using the previous lecture. So the thing that you see here is going to be, hey, how would we know that it's going to be y squared? Okay, so that is going to be our main thing for this lecture. So how would we know? So this one we know y squared by guessing. Okay, so this one we just guess y squared. Okay, however, for this one, what should we know about this one? What will be the thing that we're gonna multiply to the whole thing, and it's gonna make the equation to be an exact equation. Okay, so we need the way to find the integrating factor. Okay, so it's gonna be, how would we find the integrating factor? So we have mu xy, okay, is an integrating factor. So if you have mu xy is an integrating factor, the thing that you have is gonna be, you're gonna multiply mu to the whole equation. Okay, so after you multiply mu to the whole equation, it's gonna make the equation turn out to be an exact equation. Okay, so this one turned out to be exact. Okay, so it's exact. So when you have this guy is an exact equation, so it means that when you find derivative of the purple guy, okay, so you have the derivative of the purple guy, it's gonna turn out to be equal to derivative of the green one. So the green one is mu ny. Okay, so this one is going to be mu ny. Sorry, mu n. So you have derivative with respect to y of mu n equal to derivative with respect to x of mu n. Okay, and here you use product rule. Okay, so here you use the product rule, and the thing that you get is going to be the first derivative of the second plus the second derivative of the first. And then you're gonna simplify by, you have mu on the same side. Okay, so you will have mu on the same side. So you're gonna gather mu on the same side, the term without mu on the other side. And after simplification, you're gonna divide the whole thing by 1 over mu. Okay, so you divide also the whole thing by 1 over mu. And this will be giving you this equation. Okay, so you get 1 over mu, and you gather 1 over mu on the same side, so you get n d mu dx minus m d mu dy, and you see that, hey, why did I do that? I do that because you see this term and this term are the term that we use for checking exactness. Okay, so they are the term that we use for checking the exactness. That computed, that we compute for checking exactness. Okay, so you see the mdy and the ndx appear in the calculation before, but when you like to check whether it's going to be exact equation. If we assume further a little bit that, okay, if we assume further a little bit that your mu turn out to be the function in x only, okay, if we assume only mu is the only function in x, so you're gonna get the dy the mu dy equal to 0, okay, because you have no y, okay, that because I'm gonna show you in the example. And you're gonna be able to compute this equation. Okay, so the thing turned out to be you're gonna have this guy disappear, and you're gonna have this term together with this term that you're gonna divide both sides by 1 over n. So the calculation will lead you to only mu, okay, and this guy, and this one turned out to be the function in x only, and we're gonna get 1 over mu fx, and you get 1 over mu d mu equal to fx dx, that you can integrate both sides, and you get log mu equal to integrate fx dx, and you would get mu equal to the exponential of integrate fx dx. Okay, this one a little bit confusing, but I will show you in the example. Okay, let's do this one. Okay, so when you have this one, you have your m. Okay, so you have your m and you have your n. Let's use some color. So let's use the green and the blue one. So let me choose the one that not quite close. Okay, so I use the green and the blue one like this. I have my m and I have my n. So I will begin by dm dy for checking the exactness. So this would give you 6y, and you have dn dx. Okay, dn dx is gonna be 2y. Okay, and so you see that they are not identical, so they are not the same, so it's not exact. So they are not exact. So you're gonna subtract them. We subtract them. Okay, so we subtract them, so you get dm dy minus dn dx equal to 6y minus 2y. Okay, so it's gonna turn out to be 6y minus 2y, and you would get what? You would get 4y. Okay, so you would get 4y. This is gonna be dm dy minus dn dx. And then go back here. You see that when you subtract dm dy minus dn dx, you're gonna divide by n. The thing that you need to know is going to be n come from this line, okay, and you divide by n both sides in order to get rid of n. So this term already equal to 0, and we need to get rid of this n. So we get 1 over n like this. And the thing that I will teach you to memorize is going to be, you see that this one is N, this one is M, and this one is N. They kind of alternate each other. So you have 1 over N, the M, the N, like this. Okay. So for this one, you get 1 over N. Okay. So you get 1 over N. And then, okay, so you're gonna have my 1 over N. So you're gonna divide by N. What is N? N is gonna be 2xy. I will use the orange color. Okay, so 2xy. I explain this one slowly. So for this one, you have 2xy. Okay, so it's gonna be 2xy. And this one is the orange one. Okay, and this guy turned out to be 2 over x. Okay, so this guy turned out to be 2 over x, and this one is your fx. Okay, so this one is your fx. Okay, with me so far, this is how we obtain fx. Okay, so this is, we are until this line. Okay, and you're gonna have mu equal to the exponential of the integral of fx. Okay, so that's the formula. So you're gonna have mu equal to e to the integral of fx dx. Okay, and I'm gonna highlight some color. So this one is gonna be fx. Let's use blue one. So this one is fx. So this one is fx. Okay, so fx is 2 over x. So for this one, it's going to be e to the integrate 2 over x dx. Okay. And you integrate e to the 2 over x dx, so it's going to be e to the 2 log x. Okay. We're not going to plus c. We're not going to put absolute value here because we don't need many mu. Okay. So we just need 1 mu. The purpose for mu is going to be the thing that we're going to multiply to the whole equation in order to make the equation to be an exact equation. It can be more than 1 mu. However, we just need only 1. So we don't need absolute value, because when you put absolute value, it's going to turn out to give you 2 values, positive and negative. Okay, so it doesn't matter for the calculation right now. Okay, and you may argue that, hey, why don't you plus c? Plus c will give you infinitely many mu. Okay, however, we need only 1 mu. So just integrate as usual. However, you don't need to put absolute value for log. You don't need to plus c because we just need only 1 mu. So the calculation should be simple and basic like this one. And the algebra that you have to do is here. It's going to be, you're going to move 2 up. So this one will be written in terms of log x square. Okay, so this 2 turn out to be up here. Okay, so that is going to be your 2. And then you see that e to the log will disappear. So you would get x squared. Okay, so you would get x squared. So this one will be x squared. So you have mu equal to x squared. Okay, so you see that from the long calculation, you just have mu. Okay, so I'm gonna just tell you that this will be your first step. Okay, so this will be your first step, and this will be your second step, and the mu will be your third step. Okay, so that is going to be 3 steps so far. And the fourth step will be, you would multiply the whole equation by x squared. Okay, so you would multiply the whole equation by x squared. So let me try to copy this guy. Okay, so I'm gonna take the screenshot. Okay, and I copy this one. Okay, so this one is the original equation. I gonna multiply this equation by x squared. Okay, so you multiply this equation by your mu. Okay, so this one is your mu. Let me highlight. It's gonna be mu. Okay, and it's gonna give you an exact equation. Okay, without checking it. So you just know that if you have the correct mu, the equation will turn out to be an exact equation, and we're gonna be able to find uxy. So for this one, it's gonna be 3x squared y squared dx plus 2x cubed y dy equal to 0. Okay, so you just multiply the whole thing by mu, and this is the calculation that you have. So you're gonna solve for uxy. So you're gonna solve for uxy. It's come from integrate 3x squared y square dx. Okay, so you integrate 3x squared y squared dx. So this one will be what? You integrate with respect to x, so it's going to be 3x cubed over 3y squared plus, okay, so I don't know what to plus yet. So for this one, you get rid of 3 and 3, and you're gonna differentiate with respect to y. Okay, so you dy, okay, so you differentiate with respect to y. So this will give you 2x cubed y, and you see that this one will cross out. Okay, so we will cross this one out, and you integrate 0 dy. Okay, and integrate 0 dy, this one will be 0 plus c. Okay, and you have uxy equal to x to the third y squared plus c equal to 0 for general solution. Okay, that's all. So this will be how we solve this example. A little bit longer than you expected. Okay, a little bit longer than you expected. However, it's gonna consist of about like 5 steps. Okay, so it's gonna turn out to be about 5 steps. So it's gonna be step 5 that you get the general solution uxy here. Okay, so it's gonna be about 5 steps that you may have to do. Okay, so you may ask me, hey, what happened if it turned out to be exact? You see that if it turned out to be exact, this term turned out to be 0, and the integrating factor turned out to be nothing. So it's going to turn out to be just constant. So you don't need to multiply anything. So that also the exact equation. Okay. However, for this one, the non-exact equation turned out to be in the form that you're going to have dm dy not equal to dn dx, and you're going to be able to obtain by finding the integrating factor mu. Okay, so let's conclude before I give you more example. So the thing that you will need to compute will be this box. Okay, so you will need to compute 1 over n. Okay, so it's going to be 1 over n, this one. Okay, so you need 1 over n dm dy minus dn dx, and you have mu, okay, equal to the exponential of integral of fx dx. Another way to have mu turn out to be, if this term turn out to be complicated, that I will show you in the last example, if this term turned out to be complicated, we have another choice. Another choice is this term turned out to be 0 instead. Okay, so this term turned out to be 0 instead. So you'll be able to find in terms of the mu dy. Okay, so it's going to be 1 over mu, the mu dy equal to 1 over m. Okay, so it's going to be this, come from this term 1 over m, and you have the minus sign here. The minus sign here will interchange the order. So you're gonna see that when you divide the whole thing by the minus sign, this guy gonna come first and this guy gonna come second. So you have dn dx minus dm dy. Okay, so you see the way that you see is going to be dn dx minus dm dy, and I told you before that the order turned out to be alternate. So you have m, n, and m. Before you have n, m, and n. Okay, so if you have m minus n, you're gonna divide by n. If you have n minus m, you're gonna divide by m. Okay, it's depend on the calculation that you have. Okay, and it's going to turn out to be the function in y that I will show you in the last example. Okay, let's do example 1. Okay, so for this one, you would get m. Okay, so you would get m and n respectively in this way. So for this one, let me highlight this one for m and for n. Okay, so you would have your m and your n. Okay, so you get dm dy, you get dm dy. Dm dy turn out to be, you find derivative with respect to y, so it's going to be 4x plus 6y, and dn dx. Okay, dn dx, you should multiply this one to be x squared plus x squared plus 2xy. So this one is going to be 2x plus 2y. Okay, so it's going to be 2x plus 2y. So you see that these guys are not identical. Okay, so it's turned out to be not exact. When you have this one not exact, you're gonna find 1 over n dm dy minus dn dx. Okay, so you're gonna just have 1 over x x plus 2y. Okay, so this one is gonna be your n that I will use the yellow color. Okay, so you see I use the yellow color to make you see this one clearer. And you're gonna just have the mdy copied out. Okay, so it's gonna come from these two guys. So the thing that you're gonna have is gonna be 4x plus 6y minus 2x minus 2y, kind of. Okay, let me write them down. So it's gonna be 4x plus 6y, subtract by 2x plus 2y. Okay, and for this one you would get okay, so for this one you get 4x minus 2x, so it's going to be 2x, and 6y minus 2y, so you get 4y, and you have everything over x plus 2y, so you get 2x plus 2y over x plus 2y, and you get rid of these two. So you basically left with 2 over x. Okay, so you basically left with 2 over x. So this one will be your fx for mu. Okay, so this one is going to be your second step. This one your first step. The third step, Okay, the third step will be you have mu equal to e to the integrate fx dx, and your fx dx is the green one. Okay, so your fx dx is the green one. So this will be just e to the integrate 2 over x dx. Okay, and you have e integrate 2 over x, so it's going to be 2 log x. Okay, and this one is going to be e log x squared. Okay, so this is how we have square here. Okay, and this one is log x squared, and e and log will cancel each other to obtain just x squared. Okay, to obtain just x squared. So you have mu equal to x squared ready for the fourth step. So you have mu equal to x squared ready for the fourth step. And then you're gonna just have to copy the question. Okay, so let me grab the question, the whole thing. Take the screenshot. So for the fourth step, okay, for the fourth step, you're gonna multiply the whole equation by mu. So you have x squared multiplied to the whole equation, okay? And this one will give you 4x to the third y plus, okay, 3x squared y squared minus x to the third dx. Okay, so this one will be just dx plus, okay, you have x to the fourth. Okay, so you have x to the fourth plus 2x cubed y. Okay, so you have 2x cubed y dy. Okay, so this one you know that it is exact equation. Okay, so this equation turned out to be an exact equation. So we're gonna find u. Okay, so the fifth step will be you're gonna find u. So for u x, y, okay, so for u, x, y, you see that I'm gonna pick the second one to integrate because this one shorter. Okay, so this one is shorter. So we're gonna integrate the shorter one. So you have x to the fourth, 2x to the third y dy. Okay, so you're gonna integrate this one, you get x to the fourth times y. Okay, so you are integrating with respect to y, be careful. And for the second one, you're gonna integrate y, so it's gonna be 2x to the third, 2, not 2, y squared over 2. Okay, so that is gonna be this one that will allow us to take get rid of 2 also. Okay, and the next step I'm gonna compute ddx. Okay, so we find the partial derivative with respect to x. So this one is going to be 4x to the third y, and this one derivative with respect to x will be 3x squared y squared. Okay, so for this one you can cross these two out. Okay, so you cross these two out and you're gonna continue copy down integrate x cubed dx. Okay, so you're gonna compute negative, come from negative side here. Okay, negative x cubed dx, and the final answer will be x to the fourth y plus x to the third y squared, and you integrate x cubed dx, so you get x to the fourth over 4. Okay, and you're gonna add by your C. Okay, so you're gonna add by your C. And this one will be equal to 0 for final answer. So you have UXY. You may ask me, okay, I'm not quite sure that I explained this one already. Why do I need 0 on the other side? You need 0 on the other side. It's come from the other side of the story. Okay, so it's come from the other side of the story. The thing that we are doing turn out to be only on the left side, and on the right side it stays 0. So you need to copy 0 in order to obtain the general solution. Okay, so this one is the general solution. Okay, so this one is the general solution. If we know, okay, if we know y2 equal to 1, we can find C and obtain the particular solution by, okay, if we know y2 equal to 1, okay, we'll be able to find C and obtain the particular solution by, how could we find this one? So you have x equal to 2, y equal to 1, x equal to 2, y equal to 1, so you get 2 to the 4th times 1, 2 to the 3rd times 1 square, okay? And you have 2 to the 4th over 4 plus C equal to 0, okay? So this one is 16 plus 8, okay? Minus 8, okay? So not minus 8, not minus 4, plus C equal to 0. So you would get C equal to negative 20. Okay, so you have C equal to negative 20, and the particular solution is okay. So you copy everything down and you gonna replace C with negative infinity. So let's copy this guy. Okay, and you're gonna replace C with negative 20 that you have from the calculation. Okay, so that is gonna be your C, and that will be your final answer. Okay, so we have first the general solution, and after, if we know something further, like y2 equal to 1, you're gonna be able to find C, and this is how we find the particular solution for the non-exact equation also. Okay? For number 2, okay, so for number 2, you're gonna have y times x plus y plus x plus 2y minus 1 dy, okay? So for this one, again, you're gonna have m and have n, okay? So you have your m and you have your n here, okay? So that will be my m and my n, okay? So let's multiply this one to ease the calculation. Okay, so this one is going to be xy plus y squared. So you compute the m dy, you compute the m dy, so it's going to be x. You compute, it's going to be x plus 2y, sorry. And you have the n dx, okay, dn dx is gonna turn out to be 1, okay? So they're not the same, so this one turned out to be not exact, okay? So this one turned out to be not exact. So you're gonna have to compute, so this is the first step. The second step, you compute 1 over n dm dy minus dn dx. So it's gonna be 1 over x plus 2y minus 1, okay? And dm dy turn out to be x plus 2y minus 1, okay? So this guy turned out to be just 1, okay? So this one disappear. So this one turned out to be 1, and this one equal to fx. Okay, so that's our fx that we'll use in the third step. And you're gonna have mu equal to e to the integrate of fx dx. So this would lead you to your 1. So it's gonna be e integrate 1 dx. Okay, so this one will be e to the x. Okay, no need to plus c anything. So it's gonna be just one integrating factor that we need. And the fourth step will come from, we're gonna take a screenshot for this guy. Okay, take a screenshot, copy, and we get this term. Okay, so that my fourth step. Okay, so you multiply the whole thing by mu, which is e to the x that you found in the third step. So you have mu equal to e to the x, okay? And that will lead you to x, y, e to the x, okay? Let group x together because we're gonna integrate. So it's gonna be y x e to the x plus e to the x y dx plus, okay, so you have x e to the x plus 2y e to the x minus e to the x dy equal to 0. Okay, so this one turned out to be exact. Okay, so this one turned out to be exact. And you're gonna, okay, and you're gonna have u, okay, so you're gonna have u in terms of, okay, so u, x, y, so this one is the fifth step. For u, x, y from this calculation, you're gonna have to pick one to integrate. So the thing that you may pick is gonna be this one because it's shorter. Okay, so this one is shorter. However, if you pick this one, okay, so let's just pick this first one and to see the problem. So you integrate y x e to the x plus e to the x y dx. So when you integrate this guy, you need to integrate x e to the x dx. And this one is going to be by part that we have last semester. Okay, and last semester, if you remember this one correctly, this one is going to be e to the x minus e to the x. Okay, so this one can be integrate. However, this one is not going to be nice. It's going to turn out to be using the integration by part from calculus 1. Okay, and it's turned out to be x e to the x minus e to the x and plus c. Okay, so this one can be done by using by part. Okay, so this one we're gonna avoid. Okay, so we can avoid this by using another term. Okay, so we can avoid this one by using another term. What does it mean? It means we can just use the blue one. Okay, so we can just use the blue one. So we have uxy. Okay, so let's use some other color. So you have uxy by integrating the blue one instead. Okay, so it's going to be integral of the blue one. Let me just copy them. Okay, so if you integrate this one, okay, it seems longer, however, it can be done. So for this one, you see that when you are integrating with respect to y, this term turn out to be just constant and no need to use by part. So it's going to be just x e to the x times y. Okay, very simple. Okay, very simple. And you integrate 2y, so it's going to be 2y squared over 2 e to the x. And you integrate e to the x dy, so it's going to be e to the xy. Okay, so it's going to be that. Okay, and you're going to find d dx. Okay, so you're going to find d dx, so it's going to be you find the derivative with respect to x of each term. So this one is going to be x. Here it's going to need to use the product rule for the first term, so it's going to be the first derivative of the second plus the second derivative of the first, and everything multiplied with constant y. Okay, and the second one turned out to be y squared e to the x. The third one is going to be e to the x times y. So this one is going to be x e to the xy plus e to the xy plus y squared e to the x minus e to the xy. And they cancel each other. Okay, so they cancel each other. And you also left with this two term. Okay, you also left with this two term, and you see that, okay, why do I have y square e to the x? I have square, sorry. Let's change this one. I forgot square, okay? I forgot square up here. Okay, sorry, here. I forgot square here, and you see that I can have these two guys. Okay, so this is the exactly the same term that we have down here. Okay, so the term here and the term here. Okay, so you're gonna cross them out. Okay, you're gonna cross them out. So this one, you cross them. So this end up give you integrate 0 dx. Okay, so this give you integrate 0 dx, and it's turned out to be u equal to, okay, so you have u x y equal to x e to the xy plus y squared e to the x minus e to the xy plus constant c. Okay, so it's going to be plus constant c for final answer. Okay, so this one turned out to be equal to 0 for final answer. Okay, so a little bit difficult because of the integral at the end. Okay, so for this one, you see that you may think that it's difficult, and the difficulty come from the plus c at the integration in the fifth step. However, we didn't use any other techniques. You have to pick nicely. You have to pick the longer one, okay, in order to get the correct answer. Okay. So for the next example, it's not look like non-exact equation, or it's not look like the usual differential equation that we have seen before, okay? However, if you adjust this one a little bit, we learn that y prime, okay, so this y prime would be just dy dx. Okay, so this y prime would be dy dx. So this guy can be written as x squared dy dx minus, okay, and you're gonna have minus x y plus 1. So let's put plus side. You have minus xy plus 1 and equal to 0, okay? And this will allow you to get xy minus x squared dy plus negative xy plus 1 dx equal to 0. And for this one is the red guy, and this one is the yellow guy, okay? So this one is gonna be your m and your n that will be used in the first step respectively, okay? So you're gonna have the first step, okay? So you have dm dy, dm dy is gonna be negative x, okay? So dm dy is gonna turn out to be negative x, and dn dx, okay? So dn dx is gonna be y, okay, so it's gonna be y, and you gonna have, okay, y, and you gonna have 0, okay, so it's gonna be, no, minus 2x, okay. So this one, they are not identical, so it's not exact. Okay, so it's turned out to be not exact. And you're gonna compute, okay, dm dy subtract dn dx, okay, and you're gonna have to divide by n, okay. So this one will be 1 over xy minus x squared, and you have minus x minus y minus 2x, okay? I will leave you to do this one before I give you the solution. So this one, you're gonna continue finding the fx, okay? So you're gonna get fx, and you're gonna proceed by doing the third and fourth and fifth step, okay? So that is gonna be, I'm gonna leave you this one to calculate on your own, okay? So this one, you can see that you can just pull out x and you get y minus x and so on, okay? So please do this one, and I will give you the solution during the recitation to see whether you understand and be able to do this one on your own. Okay, I'm gonna continue by number 4, okay? Number 4, you see that you have m and n written quite clear, okay? So this one will be m, this one will be n. So this one will be m, this one will be n, okay? So you're gonna compute dm dy is gonna be, dm dy turn out to be, hey, turn out to be 0, yeah. And you have dn dx, it would be e to the x cot y, okay? So this one is your first step, okay? And they are not identical, so it's gonna be not exact. So for this one, okay? So for this one, you have number 2, okay? So it's gonna be 1 over n dm dy minus dn dx. It's gonna be 1 over e to the x cot y plus 2 cosec y. Okay, and you have dm dy, dm dy is 0, dn dx is e to the x cot y. Okay, so this one I'm gonna say that it's very complicated. Okay, so this one is very complicated, and you not be able to simplify. Okay, so very complicated, not be able to simplify. Okay, so it can happen that when you use 1 over n, okay, dm dy minus dn dx turn out to be complicated like this one. Okay, so we're gonna use other formula. Use another formula. Okay, so use another formula. So what is another formula? Another formula will be 1 over m dn dx subtract by dm dy. Okay, why did I be able to write this one? Very easy, because I know the alternate. Okay, m, n, and m. Okay, so it's going to be alternate, like I told you before. Why this one is more computable? Because you see that 1 over m, the m turned out to be the red guy. Okay, so and the red guy turned out to be 1 over e to the x. Okay, and this one turned out to be very simple. Okay, and you have the n dx subtract by dm dy, dn dx, dn dx. So it's gonna be e to the x cot y subtract by 0. Okay, they come from here, dn dx, okay, and dm dy, okay, and you see that it's gonna turn out to be cancel, and it's gonna turn out to be cot y. Okay, so you see, hey, very simple. And this one is your gy, okay, the function in y that we use notation g instead. Okay, so we have something nice in the second step already. So for the third step, the mu turned out to be e to the integrate gy dy. Okay, so this one I use orange color. Okay, so this one is gonna be gy dy. So for this one, it's gonna be e to the integrate cot y dy. So for this one, it's gonna be cot y. Okay, and integrate cot is going to be log psi y without absolute, because I told you before that we need only one integrating factor, so we don't need absolute that gonna make us plus or minus. Okay, so that is gonna make the calculation more complicated, and we don't need it right now. And this one, you get rid of this guy, and you would just give me psi y for integrating factor. Okay, so I'm going to use the pink color. Let's use the green. So you have psi y, okay? And the fourth step, okay? The fourth step will be you're gonna take a screenshot for this one. Okay, so you're gonna take the screenshot for this one, and you're gonna have multiply. I need to take the screenshot, not copy. Yay. Okay, take screenshot, copy, and you would get this term, and you gonna multiply with the green one. Okay, so you gonna multiply this guy with psi y. Okay, so you multiply with the green one, and this one turned out to be e to the x psi y dx plus, okay, e to the x psi y cot y plus 2y psi y cosec y equal to 0, okay, and this guy is exact, this guy is exact, and I forgot dy, sorry. I have dy equal to 0, and we need to do to play with algebra a little bit. Sin y cot y is gonna be cot is cos y over sin y, and you get rid of these two, okay? So you're gonna have only cos y, and this guy cosec is gonna be 1 over sin y, okay? So it's gonna be sin y, 1 over sin y, and they get rid of each other also. So this would lead you to sin y dx plus e to the x cos y, okay, plus 2y dy equal to 0, okay. I will let you do the fifth step on your own, okay. So uxy equal to, so please do this one, and I will ask you to find the particular solution. Okay, so when you have this one, find the particular solution. Okay, if y0, not y0, let's think about this one a little bit. Y pi, y pi equal to, not pi, y0 equal to pi. Let's use y1 equal to pi, equal to, actually, I gonna have it more difficult, root pi, okay? So find the particular solution if I give you further that y1 equal to root pi. Okay, so please finish this one by finding the general solution first and then find the particular solution if you know y1 equal to root pi for me. Okay, so this is it. It's gonna be a little bit longer than the previous one because this one gonna consist of about 5 steps. Okay, and you see the fifth step that you have to use the previous lecture on the exact equation. Okay, so we almost done, and I would suggest you to do these exercises in order to gain the understanding for exact equation and non-exact equation. I will discuss this one during the recitation also, that some of you may have problem doing this one. Okay, okay, so that would be all. Okay, and see you again next week.